Is anybody out there? Let's look at sound waves. So we're going to use this video to understand sound waves. So by the end of this video, you should be able to label a longitudinal wave. You should be able to explain how sound actually travels through a solid, liquid, and gas. And you should be able to link loudness and pitch to the different features of a sound wave and understand how particles are moving the energy of the sound and how that works in longitudinal waves. So let's just remind ourselves what a longitudinal wave is, and you can see it moving along in this image. A longitudinal wave is where the medium, that's the solid, liquid, or gas, oscillates, which means moves backwards and forwards in the same direction as the wave. So a longitudinal wave is moving in the same direction as the wave direction. An example of this obviously is sound waves, as the air particles bump into each other, carrying the sound to your ear. So we have different features of a longitudinal wave. We have compressions. That's where the particles are bunched together. So there's a compression. We have a rarefaction. And a rarefaction is where the particles are spaced out. And we have other features like the wavelength. This is the distance between one compression and the next, or perhaps from one rarefaction to the next. And this is similar to how the wavelength of a transverse wave is measured between two crests or two troughs. So we just met a few definitions there, so if you need to pause this video and reread those definitions, we've met them before, just to remind yourself of wave words. So let's have a think about sound in particular, and here we have a rather awesome looking drum kit. So have that in your mind as we think about sound waves. So sound waves are examples of longitudinal wave, and they are produced by the vibrations of an object. And this is often an instrument, and the instrument then causes the air to vibrate, and that's how the sound energy gets to your ears. So sounds can be made by hitting something. You can make sounds by vibrating a string. You could vibrate a reed, like in a clarinet, or you could just vibrate your lips. And you can have a go at doing that right now. So what are some features of sound that can change? So think about some words you could use to describe properties of sound. So it might be loud, it might be soft, it might be harsh, it might be high-pitched, it might be low-pitched, it might be melodic, it might be tuneful, or it might be discordant and kind of jarring. So think about how you could link some of those properties to the properties of longitudinal waves. So think about words like amplitude and wavelength, and see how they might link to things like loudness and pitch. So when sounds are loud, they are actually made by vibrating the object more and making waves with larger amplitude. Soft sounds, you vibrate the object less, and therefore you have a smaller amplitude. If you're looking instead at pitch, you have to make the vibration faster. In other words, it has to have a larger frequency or higher frequency. And if you have a low pitch sound, then you vibrate slower and you have a smaller frequency. But all sounds need to travel through something, and that something is called a medium. So sounds do not travel in space through a vacuum, and the speed at which sound travels is determined by the type of medium they're traveling in. So if something is dense and the particles are close together, the energy can actually move faster from particle to particle. So sound waves actually travel faster through dense things. Let's have a look at this picture here. So we have a solid in the top, we have a liquid in the middle, and we have a gas at the bottom. And you'll see that in the solid, the waves are moving quickly across the yellow surface. If the same sound goes through a liquid, they're moving a little bit slower, and in a gas, that's the slowest. So solids are very densely packed. That's why the particles can bump into each other quickly and pass their energy along. Liquids are less dense, and the gases are the lowest density. So the waves travel the slowest through a gas.